In 2024, Tristan Dunia's emergency medical evacuation cost $180,000 and stranded 12 visitors for 2 additional months when rough seas prevented ship docking. This wasn't some newly discovered planet or underwater city. This was a place with GPS coordinates where satellite imagery shows every building, yet reaching it remains nearly impossible. Take Mauna Kea, where new sonar measurements reveal the mountain extends 35,432 feet from seafloor to summit, making it Earth's tallest peak. But its true base has never been reached by humans despite decades of attempts. In our hyper-connected world of 2025, where 70% of Earth's surface remains ocean and nearly half of rural roads receive no regular transit service, these places exist in a bubble of complete isolation. The question isn't whether you can find them on a map, but whether modern technology actually makes them more accessible or creates entirely new barriers. The new age of exploration. Today we carry more computing power in our pockets than NASA used to reach the moon. Yet this technological revolution has created a dangerous illusion. Amazon drones drop packages in backyards. Starlink satellites beam internet to the middle of nowhere. And your smartphone can pinpoint your location within 3 feet anywhere on Earth. We have real-time traffic updates for every highway, weather forecasts accurate to the hour, and emergency services that can locate you from your phone's GPS signal. This technological blanket makes it seem like every corner of our planet is within reach. The reality tells a different story. While you can order food delivery to most addresses in major cities, there are places on Earth where a rescue helicopter cannot reach you even if you have a satellite phone and perfect weather. Your GPS might show you exactly where you are, but it cannot create a bridge across a 1,000-mile stretch of ocean or neutralize toxic volcanic gases that melt equipment. Modern technology has actually made some remote locations harder to reach than they were 50 years ago. Environmental monitoring systems now detect visitors to sensitive areas, triggering automatic alerts to authorities. Thermal imaging satellites can spot unauthorized expeditions from space, leading to immediate intervention. Advanced weather prediction models reveal dangerous conditions weeks in advance, but they also show that safe windows for travel have shrunk dramatically due to climate change. Climate change has rewritten the rules of accessibility across the globe. The 2024 collapse of sections of the Thwaites Glacier altered Antarctic access routes that researchers had used for decades, forcing expeditions to find entirely new approaches through unstable ice fields. Arctic sea ice minimums are down by 4.6% per decade since 1979, and melt has extended open water seasons by weeks, creating unpredictable conditions where vessels can be trapped in ice one day and exposed to violent storms the next. Rising sea levels have submerged landing strips on remote islands, while melting permafrost has destabilized mountain routes that took decades to establish. Political instability has created new barriers that technology cannot overcome. The Republic of Abkhazia's disputed status around Varovkina cave exemplifies how territorial conflicts block access to remote locations. Multiple governments claim authority over the region, creating bureaucratic mazes where expeditions require diplomatic clearance that can take years to navigate. No amount of GPS accuracy can help you navigate through an active war zone, and no satellite phone can negotiate safe passage through territories controlled by hostile forces. Environmental protection laws have evolved to create absolute barriers around sensitive ecosystems. Locations that were difficult to reach in the past are now legally impossible to access, with governments implementing penalties severe enough to deter even the most determined explorers. These restrictions often carry prison sentences measured in years, not months. The barriers we face today divide into 4 distinct categories. Legal barriers include international treaties, military restrictions, and environmental protection laws that carry severe penalties. Environmental barriers encompass extreme weather, toxic conditions, and unstable terrain that can kill even well-equipped expeditions. Technological barriers exist where our modern equipment simply fails due to extreme conditions or electromagnetic interference. Geographical barriers remain the most fundamental, involving distances and terrain that human physiology cannot overcome regardless of technology. There are locations where expeditions routinely spend over $1 million and still fail to reach their destination. These failures are not due to poor planning or inadequate funding, but because the locations themselves present challenges that current technology cannot solve. Teams arrive with military-grade equipment, specialized vehicles, and experienced guides, only to discover that the laws of physics and human endurance create immovable barriers. The year 2024 marked a particularly dangerous period for extreme exploration. 7 major expeditions resulted in fatalities, while dozens more required emergency evacuations that cost millions of dollars and endangered rescue personnel. Success rates for reaching the most remote locations have dropped significantly since 2020. What were once considered challenging but achievable destinations now have success rates below 20%. Modern weather prediction has revealed that safe travel windows to certain locations occur only once every few years, not seasonally as previously believed. Climate change has made weather patterns so unpredictable that even short-term forecasts become unreliable in remote areas. The intersection of extreme weather, political instability, and environmental protection has created a perfect storm of inaccessibility around the world's most remote locations. The most remote locations demand survival skills that go beyond traditional wilderness training. Teams must prepare for scenarios where rescue is impossible and where a single equipment failure can be fatal. The psychological challenges of extreme isolation have proven as dangerous as physical hazards, with isolation syndrome developing within weeks of complete separation from civilization. Among all these impossible destinations, one location stands above the rest as the ultimate test of human determination and technological capability. This place has defeated every attempt to reach it, despite expeditions equipped with the most advanced technology available. The barriers protecting it are not just physical, but represent the absolute limits of what humans can achieve on our own planet. In the middle of the South Atlantic Ocean, surrounded by some of the roughest seas on Earth, lies a place where even reaching the shore is just the beginning of an impossible journey. The floating prison of the Atlantic. Tristan Dunia holds the title as the world's most remote inhabited island, sitting 1,750 miles from the nearest populated land in the middle of the South Atlantic Ocean. The island's population has dropped to just 198 residents as of January 2025, after 15 families emigrated to the United Kingdom during the previous 12 months. Young adults who left for education have chosen not to return, citing limited opportunities and growing isolation. Local authorities estimate that if emigration continues at the current rate, the population could fall below 150 by 2027, threatening essential services. Only 2 ships now provide passenger service to the island, making a combined total of 8 trips per year when weather permits. The MV Edinburgh and the SA Agulhas II operate the only regular routes, but fuel costs have increased by 280% since 2020, forcing shipping companies to reduce service frequency. Each voyage takes 6 days from Cape Town, but passengers must plan for a 1-month waiting window due to unpredictable weather conditions that can prevent docking for weeks at a time. The financial reality of visiting Tristan Dunia has become prohibitive for most travelers. A one-way passenger fare costs $495, but the true expense comes from extended stays when return journeys face indefinite delays. Visitors must budget for accommodation, meals, and activities that can stretch for months beyond their planned departure date. The medical emergency of 2024 demonstrated these risks when 12 research expedition members found themselves stranded for 8 months, exhausting their personal funds while families organized international fundraising efforts to cover mounting costs. Volcanic activity monitoring systems installed in 2024 have fundamentally changed access patterns to the island. Seismic sensors positioned around the volcano's base detect minute changes in ground stability and gas emissions. When readings exceed safety thresholds, the island's single landing area becomes off-limits to all vessels. These restrictions now limit the safe landing window to just 4 months per year, typically between January and April. The monitoring system has prevented 3 potential disasters, but has also stranded visitors who arrived during safe periods and could not leave when volcanic activity increased. Climate change has dramatically altered weather patterns in the South Atlantic, making the ocean crossing significantly more dangerous. Storm frequency has increased by 40% since 2015, with wind speeds regularly exceeding 60 knots during previously calm seasons. Wave heights now average 15 feet higher than historical norms, and unpredictable storm systems make weather forecasting unreliable beyond 48 hours. Ship captains report that conditions once encountered monthly now occur weekly, forcing frequent route changes and extended journey times. Communication limitations have worsened due to satellite capacity constraints and increased costs. Internet access is restricted to 2 hours per day for the entire island, shared among residents and visitors. Phone calls to the outside world cost $12 per minute, making regular communication financially impossible for most visitors. Email services are limited to text-only messages under 500 characters, and video calls are prohibited except for medical emergencies. Many visitors report feeling completely cut off from the outside world within days of arrival. The psychological toll of extreme isolation has become a documented concern. Visitors commonly experience anxiety attacks, depression, and sleep disturbances that can persist for months after returning to populated areas. The island's medical facilities lack the resources to address severe psychological reactions to isolation, leaving visitors to cope with these effects without professional support. The combination of communication restrictions and indefinite stay extensions creates a perfect storm for mental health challenges. Reaching St. Mary's Peak, the island's highest point at 6,765 feet, now requires specialized volcanic gas monitoring equipment costing over $8,000 per expedition. Increased volcanic activity has created dangerous concentrations of sulfur dioxide and toxic gases at elevations above 4,000 feet. The specialized equipment includes gas detectors, emergency oxygen supplies, and protective suits that must be worn above the tree-line. Local guides refused to lead expeditions without this equipment after 2 climbers required emergency medical treatment for gas exposure in late 2024. The track record for successful visits has deteriorated sharply. 3 of the last 5 organized expeditions resulted in extended unplanned stays ranging from 2 months to nearly a year. Weather-related delays account for 60% of extended stays, while mechanical problems with transport vessels cause another 25%. Insurance companies now classify any trip to Tristan Dunia as high-risk adventure travel, with coverage limitations that leave most costs uncovered. Despite these overwhelming challenges, Tristan Dunia represents just one type of impossible destination. The island's barriers are primarily logistical and financial, created by distance and weather patterns that can be predicted even if they cannot be controlled. But there are places on Earth where the very environment itself has become actively hostile to human survival, where temperatures have risen beyond the limits of human endurance, and where the landscape shifts constantly to erase any hope of navigation. The desert's deadly mathematics. The Central Sahara Desert has become a mathematical equation where human survival simply does not compute. The German Geographic Institute's 2024 expedition to reach the exact center ended in tragedy when 3 team members died from hypothermia during a heat wave that pushed temperatures to 136 degrees Fahrenheit. The expedition had planned a 21-day journey using GPS coordinates to navigate to the mathematical center point located in southern Libya. Team leader Dr. Klaus Hartmann later testified that their industrial-grade thermometers stopped functioning when ambient temperatures exceeded their maximum reading of 135 degrees Fahrenheit. Medical examiner reports showed that the victim's core body temperatures reached 112 degrees Fahrenheit, well beyond the threshold for organ failure. Summer temperatures in the Central Sahara now regularly exceed 130 degrees Fahrenheit due to climate change effects that have intensified over the past 5 years. Weather stations positioned throughout the desert have recorded ground temperatures reaching 176 degrees Fahrenheit, hot enough to cause third-degree burns through shoe soles within minutes. The traditional cooler months of November through February now see daytime temperatures that would have been considered extreme summer heat just a decade ago. The heat creates a thermal barrier that extends from ground level to over 200 feet in altitude, making helicopter rescues impossible during peak temperature periods. Reaching the Sahara center now requires an 800-mile overland journey from Algeria after Libya closed most airports to civilian traffic. The route crosses 3 border checkpoints, each requiring separate permits and inspections that can delay expeditions for weeks. Fuel availability becomes critical since the nearest gas stations are over 400 miles apart, and carrying enough fuel requires multiple support vehicles. The Algerian government requires expeditions to post bonds of $50,000 per person to cover potential rescue costs. Military GPS jamming in the region has made navigation exponentially more dangerous for desert expeditions. The jamming affects civilian GPS devices within a 300-mile radius of suspected military installations, leaving explorers without accurate positioning data for days at a time. Traditional compass navigation becomes unreliable due to magnetic anomalies caused by iron or deposits scattered throughout the central desert. Emergency beacons and satellite communicators also experience interference, preventing accurate location transmission to rescue services. The 2024 rescue of the Australian Desert Research Team cost $2.1 million and required 6 weeks to locate the missing expedition members. The team disappeared when their GPS systems failed simultaneously during a sandstorm that lasted 4 days. International rescue coordination involved aircraft from 3 different countries, ground teams from Algeria and Libya, and satellite tracking services from European space agencies. Rescue helicopters burned through over $800,000 in fuel costs alone, while searching a grid pattern covering 15,000 square miles. Each expedition member now requires 15 gallons of water per day to survive the extreme heat conditions, making vehicle weight a critical limiting factor. A 4-person team needs 420 gallons of water for a week-long expedition, weighing over 3,500 pounds without containers. The water must be stored in specialized containers that prevent evaporation and maintain temperatures below 100 degrees Fahrenheit to avoid scalding. Additional cooling equipment adds another 500 pounds per vehicle, reducing cargo capacity for food, medical supplies, and navigation equipment. Shifting sand dunes have eliminated virtually all fixed landmarks in the Central Sahara, creating a constantly changing landscape that defeats traditional navigation methods. Satellite imagery shows that major dunes migrate up to 50 feet per year, burying rock formations and vegetation that previous expeditions used as reference points. Wind patterns have shifted due to climate change, causing sand movement in directions that historical records do not predict. The landscape literally transforms between satellite image updates, making current maps obsolete within months of publication. Political complications have reached critical levels as Libya, Chad, and Niger each claim jurisdiction over portions of the target area containing the desert's geographic center. Each government requires separate permits, insurance bonds, and escort arrangements that often conflict with requirements from the other authorities. Military checkpoints from all 3 countries operate within the disputed zone, leading to expeditions being detained by multiple forces in a single day. Expeditions require diplomatic immunity letters from their home countries and approval from the African Union to attempt the journey. Satellite phone dead zones have expanded dramatically due to increased military electronic warfare activities in the region. Communication blackouts now extend for 200-mile stretches where satellite signals are actively jammed or blocked by military installations. The dead zones shift locations unpredictably, making it impossible to plan communication schedules with support teams. Emergency communication devices experience interference that can last for days, leaving expedition members completely isolated during critical periods. The success rate for reaching the true geographic center of the Sahara has plummeted to just 12% in 2025, down from 60% in 2019. This dramatic decline reflects the combination of extreme weather, political instability, and technological challenges that have made the journey nearly impossible for civilian expeditions. Most failed attempts end in expensive rescue operations or emergency evacuations that discourage future attempts. The Sahara represents the ultimate challenge of extreme heat and political complexity, but climate change has created an entirely different category of impossible destinations. In regions where ice once provided predictable barriers, melting has created new forms of danger that combine accessibility with deadly unpredictability. The Arctic's vanishing gateway. The Gangkhar Ridge beneath the Arctic Ocean demonstrates how climate change has created the most dangerous paradox in modern exploration. Ships can now navigate routes that were impossible just 10 years ago, reaching positions directly above the ridge without breaking through solid ice sheets. The reduced ice coverage allows vessels to approach the target area during extended summer seasons that now last 4 months instead of the traditional 6 weeks. However, this apparent accessibility masks deadly new hazards that have made successful operations nearly impossible. Unstable ice conditions created by partial melting have turned the Arctic Ocean above the Gangkhar Ridge into a constantly shifting maze of debris. Massive ice chunks break away from the main pack without warning, creating floating obstacles that can crush vessels or trap them for months. These ice fields move unpredictably with currents and winds, changing the landscape of navigable water from hour to hour. Ships that successfully reach the ridge area often find their return routes blocked by ice formations that appeared after their arrival. The research vessel Kronprins. Håkon experienced this reality during a 2024 expedition when ice patterns shifted unexpectedly, trapping the vessel for 3 months in conditions that weather forecasts had predicted would remain stable. The ship's crew watched helplessly as ice formations closed around them despite satellite imagery showing clear water just days before their arrival. Rescue operations proved impossible as icebreaker vessels faced the same shifting conditions that had trapped the original expedition. Submersible operations face entirely new challenges as underwater ice debris fields extend far below the surface. Traditional Arctic diving assumed that ice obstacles existed only at the surface level, but melting patterns have created underwater ice formations that extend hundreds of feet deep. These submerged ice chunks drift with deep ocean currents, creating unpredictable hazards for submersibles attempting to reach the ridge floor. The ice debris interferes with sonar navigation systems and creates collision risks that did not exist when surface ice provided a stable reference point. Operating in this transformed Arctic environment requires specialized icebreaker vessels that cost $45,000 per day to charter, with minimum commitments of 30 days due to the unpredictable nature of ice conditions. These vessels must carry extended supplies and fuel reserves, since rescue operations may be impossible if ice conditions deteriorate. The daily rate covers vessel operation, specialized Arctic crew, and insurance premiums that have increased by 400% due to the elevated risk profile. The minimum 30-day commitment reflects the reality that shorter expeditions cannot account for the time required to reach the ridge, conduct operations, and return safely through changing ice conditions. The changing Arctic ecosystem has introduced aggressive polar bear encounters as their traditional habitat shrinks and becomes fragmented. Polar bears now approach research vessels and camps with unprecedented boldness, driven by desperation as their traditional hunting grounds disappear. The bears have learned to associate human activity with potential food sources, making them dangerous to expedition members both on ships and during shore-based operations. Their swimming capabilities allow them to reach vessels anchored far from visible ice, creating security concerns that did not exist when stable ice sheets provided predictable bear habitat. Russian territorial claims have created severe political complications by declaring large portions of the Gangkhar Ridge off-limits to foreign researchers. The Russian government considers the ridge part of its extended continental shelf claim, requiring special permits that are rarely granted to non-Russian expeditions. Military vessels patrol the area and have intercepted foreign research ships, forcing them to leave the region immediately. The territorial dispute extends beyond surface claims to include restrictions on underwater research and sample collection throughout the ridge system. Traditional Arctic equipment experiences frequent failures due to new temperature fluctuation patterns that repeatedly freeze and thaw sensitive components. Electronic navigation systems malfunction when exposed to rapid temperature changes that can vary by 40 degrees within hours. Communication equipment designed for stable cold conditions fails when repeatedly cycled through freeze-thaw patterns that create condensation and ice formation inside sealed units. Emergency survival gear, including heating systems and water purification equipment, cannot function reliably in the unstable temperature environment. The technological challenges extend to basic ship operations as hull materials and engine systems experience stress from rapid temperature changes. Ice formation on ship surfaces creates weight distribution problems that affect vessel stability and navigation accuracy. Fuel systems require constant heating to prevent freezing, but the heating systems themselves malfunction when exposed to extreme temperature variations. Communication with support teams becomes unreliable as atmospheric conditions created by temperature fluctuations interfere with satellite and radio transmissions. Only 2 successful expeditions reached the Gangkhar ridge floor in 2024, representing a dramatic decline from 8 successful missions in 2020. This decrease reflects the compound effects of unstable ice conditions, political restrictions, and equipment failures that have made operations exponentially more difficult. The successful expeditions required specialized equipment, extended timelines, and budgets exceeding $3 million each. Climate change has created the ultimate irony in Arctic exploration, making the Gangkhar Ridge simultaneously more accessible and more dangerous than ever before. Ships can reach the area more easily than in the past, but the conditions they encounter upon arrival present risks that previous generations of Arctic explorers never faced. Yet even the Arctic's challenges pale in comparison to destinations where the very measurements of depth and distance continue to change as scientists make new discoveries that the abyss gets deeper. The Woods Hole Oceanographic Institution shocked the scientific community in March 2024 when their latest sonar mapping revealed that Challenger Deep extends 127 feet deeper than any previous measurement had detected. The discovery came during a routine bathymetric survey using newly developed quantum sonar technology that can penetrate sediment layers previously thought to be solid rock. Dr. Patricia Chen, lead researcher on the mapping project, announced that the true depth reaches 36,200 feet below sea level, making it deeper than Mount Everest is tall. The additional depth was hidden beneath accumulated sediment and geological formations that older sonar systems could not distinguish from the actual seafloor. This revelation meant that every depth record claimed over the past 60 years was technically incorrect, and more importantly, it meant that existing submersible technology was inadequate for reaching the true bottom. The depth discovery invalidated the design specifications of every deep-sea submersible currently in operation worldwide. Submersibles engineered to withstand pressure at 35,876 feet cannot survive the additional 127 feet without catastrophic hull failure. The pressure difference at the newly discovered depth equals an additional 360 pounds per square inch, which exceeds the safety margins built into current vessel designs. Triton Submarines, the leading manufacturer of deep-sea exploration vehicles, announced that their flagship model would require 18 months of re-engineering and testing before it could attempt the new depth. The redesign process involves strengthening hull materials, upgrading life support systems, and completely rebuilding pressure compensation mechanisms. Each modification adds weight and complexity that affects the vessel's maneuverability and operational range. Getting to the Mariana Trench requires flying to Guam, where flight costs have increased by 300% since 2020 due to reduced airline routes following the pandemic. United Airlines now operates only 3 flights per week to Guam from the continental United States, down from daily flights that were available before travel restrictions decimated Pacific route profitability. A round-trip ticket from Los Angeles to Guam now costs between $4,200 and $6,800 depending on the season, compared to $1,400 in 2019. Hotel accommodations in Guam have increased by 180% as reduced tourism capacity coincides with increased demand from research teams and wealthy adventurers seeking to dive the trench. The 2024 submersible incident that captured international attention began as a routine dive to collect geological samples from the trench floor. The submersible Hadal Explorer experienced a catastrophic power failure at 32,000 feet depth, leaving 2 crew members trapped in complete darkness with limited life support. The vessel's emergency ballast system partially failed, preventing it from ascending to the surface under its own power. Rescue operations required coordination between the U.S. Navy, Japanese Maritime Self-Defense Force, and private deep-sea recovery specialists. The rescue took 72 hours to execute and cost over $18 million. Only 3 submersibles worldwide can now reach the newly confirmed depth of Challenger Deep after the recent discovery required updated safety certifications. The limiting factor, operated by Caledon Oceanic, underwent 6 months of modifications and testing to achieve certification for the new depth. The Chinese submersible Fendu's completed similar upgrades, but remains restricted to Chinese research missions. The Russian vessel Consul is currently undergoing pressure testing and may not receive certification until late 2025. Every other deep-sea submersible in existence lacks the structural integrity to survive pressure at the true bottom of the trench. Diving costs have reached $1.2 million per descent due to increased insurance requirements, specialized equipment needs, and enhanced safety protocols. Insurance companies now require expeditions to carry coverage for potential rescue operations that can exceed $20 million in emergency situations. The insurance premiums alone account for $200,000 of each dive's cost. Specialized equipment, including enhanced life support systems, emergency communication devices, and backup power systems, adds another $300,000 per mission. Support vessel operations contribute $400,000 to each dive, with the remaining costs covering permits, safety inspections, and contingency funds. Geological surveys have discovered significant instability in the trench walls that makes descent routes unpredictable and increasingly dangerous. Underwater landslides occur regularly due to tectonic activity, creating debris fields that can damage or destroy submersibles. Seismic monitoring equipment installed in 2023 detected over 400 minor earthquakes within the trench system during a 6-month period. These earthquakes destabilize sediment layers and create rockfall hazards that pose direct threats to descending vessels. Microplastic pollution has created unexpected navigation hazards throughout the water column above Challenger Deep. Dense concentrations of plastic debris interfere with sonar systems and create false readings that can lead submersibles off course. The plastic particles reflect sonar signals in ways that mimic solid objects, making it difficult to distinguish between debris and actual geological features. Waiting lists for submersible dives to Challenger Deep now extend 4 years due to the limited availability of certified vessels and increasing demand from researchers, filmmakers, and wealthy adventurers. The 3 operational submersibles can complete a maximum of 24 dives per year when accounting for maintenance schedules, weather delays, and equipment testing requirements. Current demand exceeds 100 requests per year, creating a massive backlog that continues to grow. The statistical reality of deep-sea exploration has reached an absurd milestone. More people traveled to space in 2024 than successfully reached the bottom of Challenger Deep. Commercial spaceflights transported 47 individuals beyond Earth's atmosphere, while only 12 people completed successful dives to the deepest point in the ocean. This disparity highlights how space exploration has become more accessible than exploring the deepest parts of our own planet. Yet while we struggle to reach the deepest points on Earth, new discoveries continue to reveal that our understanding of even the most familiar landmarks remains incomplete. The tallest mountain nobody knows. Advanced sonar mapping conducted by the University of Hawaii's Deep Sea Research Institute in 2025 revealed that Mauna Kea extends 2,000 feet deeper into the ocean floor than any previous measurement had detected. The new quantum penetration sonar technology can distinguish between consolidated rock and accumulated sediment layers that older equipment classified as solid seafloor. Dr. Sarah Kawamoto, lead researcher on the mapping project, announced that the mountain's total height from its true base to summit reaches 35,432 feet, making it nearly 6,400 feet taller than Mount Everest when measured from base to peak. The additional depth was hidden beneath sediment accumulation and volcanic debris that had built up over millions of years of underwater eruptions. Millions of tourists visit Mauna Kea's summit each year, driving up a paved road that makes the peak one of the most accessible high-altitude locations on Earth. Tour buses carry visitors to the 13,796-foot summit, where they can observe astronomical observatories and enjoy panoramic views of the Hawaiian Islands. The contrast between the summit's accessibility and the complete inaccessibility of the mountain's true base creates one of geography's most striking paradoxes. Visitors can reach the top of the world's tallest mountain in 2 hours by car, yet no human has ever approached the bottom of the same mountain despite decades of technological advancement. The true base of Mauna Kea sits at a depth of 19,636 feet below sea level, surrounded by crushing pressure that equals 600 times normal atmospheric pressure. At this depth, every square inch of surface area experiences 8,800 pounds of pressure, enough to instantly crush any conventional diving equipment. The pressure environment requires specialized submersibles with titanium hulls several inches thick and pressure-resistant viewing ports made from materials that cost more than luxury cars. Human bodies cannot survive at this pressure level even with advanced life support systems, making direct exploration impossible without technological intervention. The Woods Hole Oceanographic Institution's 2024 expedition to reach Mauna Kea's true base ended in failure when their submersible Keiko 4 encountered unstable underwater terrain that prevented safe descent. The expedition discovered that the mountain's base sits on a foundation of loose volcanic debris and shifting sediment that creates constant avalanche conditions. Underwater landslides triggered by seismic activity regularly reshape the terrain around the mountain's base, making navigation routes unpredictable and extremely dangerous. The submersible sonar detected massive rock formations moving in real time as volcanic activity destabilized the seafloor. Volcanic activity around Mauna Kea has increased significantly over the past 3 years, creating underwater hazards that make approach routes extremely dangerous for submersible operations. Thermal vents now release superheated water and toxic gases throughout the area surrounding the mountain's base. The water temperature near active vents reaches 750 degrees Fahrenheit, hot enough to melt the external components of deep-sea exploration equipment. Hydrogen sulfide and other toxic gases dissolved in the water can penetrate submersible hulls through microscopic openings, creating life-threatening conditions for crew members. Reaching Mauna Kea's true base requires an expedition budget of $3.8 million for a single attempt, reflecting the extreme technical challenges and specialized equipment required for the mission. The cost includes chartering a deep-sea research vessel capable of supporting submersible operations at maximum depth, which costs $85,000 per day with a minimum 30-day commitment. Specialized submersibles rated for the required depth cost $1.2 million to operate for a single descent, including crew wages, equipment maintenance, and insurance coverage. Emergency rescue equipment and backup systems add another $800,000 to the expedition budget. The Hawaiian government implemented strict regulations in 2024 that severely limit deep-water exploration activities around Mauna Kea due to environmental protection concerns and cultural sensitivity issues. Native Hawaiian groups consider the entire mountain sacred, including its underwater portions, and have successfully lobbied for restrictions on scientific exploration that might disturb the area. Environmental impact assessments now require 18 months to complete and cost over $200,000 before any exploration permits can be considered. The permit application process requires approval from 7 different state and federal agencies, each with separate requirements and review timelines. Technical challenges at Mauna Kea's base include crushing pressure that exceeds the design limits of most deep-sea equipment, volcanic gases that corrode metal surfaces within hours, and unstable rock formations that create constant avalanche conditions. The seafloor consists of loose volcanic debris that shifts unpredictably, making it impossible to establish stable work platforms or secure anchor points for submersibles. Communication with surface vessels becomes unreliable at maximum depth due to thermoclines and electromagnetic interference from volcanic activity. The paradox of Mauna Kea challenges traditional concepts of mountain climbing and exploration achievement. Reaching Everest's summit requires weeks of acclimatization, extreme physical conditioning, and survival skills in thin air and freezing temperatures. However, the technical barriers to reaching Mauna Kea's base are exponentially more complex, requiring technology that exists at the absolute limits of human engineering capability. The success rate for Everest summit attempts approaches 60% for experienced climbers, while no expedition has successfully reached Mauna Kea's true base despite multiple attempts using the most advanced deep-sea technology available. The world's tallest mountain presents the ultimate irony in geographical accessibility, where tourists can easily reach its summit while its base remains completely beyond human reach. Yet while Mauna Kea's challenges stem from technological limitations and natural barriers, there are peaks on Earth where human laws have created obstacles that no amount of money or technology can overcome. The Forbidden Peak. Gangkhar Puensum stands at 24,836 feet in the remote Himalayas between Bhutan and Tibet, holding the distinction of being the world's highest unclimbed mountain. This peak remains unconquered not because of technical climbing challenges alone, but because Bhutan has created legal barriers that make any attempt impossible. The mountain's inaccessibility stems from a combination of strengthened legislation, cultural protection laws, and geopolitical tensions that have transformed it from a climbing challenge into a completely forbidden zone. Unlike other remote peaks that attract adventurers willing to risk their lives for glory, Gangkhar Puensum exists in a legal vacuum where even approaching the mountain constitutes a serious crime. Bhutan's 2024 Mountain Protection Act strengthened existing legislation by increasing penalties for unauthorized mountaineering to up to 10 years in prison, with no possibility of parole or early release. The law specifically targets Gangkhar Puensum and other sacred peaks, classifying any climbing attempt as a Category A felony equivalent to espionage or terrorism charges. The legislation expanded beyond simple trespass violations to include possession of climbing equipment, aerial photography of restricted peaks, and even online promotion of climbing activities in the region. Foreign nationals face additional charges, including visa violations and cultural desecration that can extend prison sentences to 15 years. The law applies retroactively to anyone who has previously attempted to organize expeditions to restricted peaks, creating legal liability for past planning activities. Satellite imagery analysis conducted by the European Space Agency in 2024 revealed that Gangkhar Puensum has become significantly more dangerous due to increased glacial instability caused by climate change. High-resolution thermal imaging shows massive ice formations that are structurally unsound, with crevasses opening and closing unpredictably throughout the year. The glacial coverage has shifted dramatically over the past 5 years, creating new avalanche zones and eliminating traditional route options that previous expeditions had considered. The mountain's north face has experienced 3 major ice collapses since 2022, each removing thousands of tons of ice and exposing unstable rock formations beneath. Glaciologists studying the imagery report that the mountain's climbing conditions change monthly due to accelerating ice movement and structural failures. The 2024 border dispute between Bhutan and China has militarized the entire region surrounding Gangkhar Puensum, creating a heavily armed zone where military forces from both countries maintain permanent positions. Chinese People's Liberation Army units have established observation posts within sight of the mountain's base, while Royal Bhutan Army Forces patrol approach routes on a daily basis. The disputed territory includes the mountain itself, with both governments claiming exclusive jurisdiction over different sections of the peak. Military commanders from both sides have issued standing orders to detain any unauthorized personnel found in the region, regardless of their nationality or stated purpose. The military presence has transformed the area into an active combat zone where civilian access is impossible and potentially fatal. Advanced surveillance technology now monitors every approach to Gangkhar Puensum using motion sensors, thermal cameras, and automated drone patrols that operate continuously. The surveillance network can detect human movement from distances exceeding 5 miles and automatically alerts military authorities to any unauthorized presence. Thermal imaging systems identify body heat signatures even in extreme weather conditions, making it impossible to approach the mountain undetected. Motion sensors buried along traditional trekking routes trigger immediate responses from security forces. Drone patrols follow programmed flight patterns that provide overlapping coverage of all possible approach routes to the mountain. Climate change has created entirely new avalanche zones on Gangkhar Puensum that pose deadly threats to anyone attempting to approach the mountain. Snow accumulation patterns have shifted due to changing weather systems, creating unstable snow loads on previously safe slopes. Temperature fluctuations now occur with such frequency that snow conditions can change from stable to extremely dangerous within hours. The mountain experiences freeze-thaw cycles that create ice layers within the snowpack, leading to unpredictable avalanche triggers. Wind patterns have changed due to regional climate shifts, creating snow cornices and wind-loaded slopes in areas where they never existed historically. The mountain's sacred status has been elevated to the highest level of religious protection in both Bhutanese and Tibetan Buddhist traditions, making any climbing attempt a serious cultural violation that extends beyond legal consequences. Religious leaders have declared that disturbing the mountain would bring misfortune to entire communities and violate fundamental spiritual principles. Local communities consider the mountain to be the dwelling place of protective deities who must not be disturbed by human presence. Cultural impact assessments now classify any approach to the mountain as equivalent to desecrating a temple or monastery. Geological surveys indicate that Gangkhar Puensum continues growing taller each year due to ongoing tectonic activity, making the mountain more challenging with each passing season. GPS measurements show the mountain gaining approximately 2 inches in height annually, while also shifting laterally due to tectonic forces. The constant geological movement creates structural instability that makes route planning impossible and increases avalanche risks throughout the region. Gangkhar Puensum may represent the last major peak that will never be conquered by humans, protected by an impenetrable combination of legal, military, cultural, and natural barriers. Yet while Bhutan's laws create absolute prohibition, other peaks face different challenges where territorial disputes have escalated beyond diplomatic tensions into something far more dangerous. The mountain in no man's land. Muchu Chhish presents the ultimate convergence of political volatility and natural barriers, where armed conflict has transformed a climbing challenge into a potential act of war. The 24,270-foot peak sits at the intersection of 3 disputed border regions between Pakistan, India, and China, making it the focal point of a complex international crisis that erupted into active military engagement in August 2024. Pakistani forces established forward positions on the mountain's southern approaches after claiming that Indian reconnaissance teams had violated the line of control. Indian military units responded by fortifying positions on the eastern ridges, while Chinese People's Liberation Army forces moved into the northern valleys, citing threats to their border security. Artillery exchanges damaged base camps and destroyed climbing infrastructure that had taken decades to establish, transforming the mountain into a militarized zone surrounded by opposing forces. All 3 armies have issued shoot-on-sight orders for any unauthorized personnel found within 15 miles of the mountain's base. Military commanders established kill zones with instructions to engage any unidentified individuals without warning. Sniper positions have been documented on prominent ridges with clear lines of sight to traditional climbing routes. Patrol units conduct regular sweeps through approach valleys using thermal imaging and motion detection equipment to identify potential intruders. Heavy artillery positioned around the mountain can shell climbing routes if necessary to prevent unauthorized access. Air defense systems prevent helicopter rescues or supply drops that might assist climbing expeditions. Radio communications in the area are monitored continuously, with any climbing-related transmissions triggering immediate military response. The International Alpine Research Team experienced this militarized chaos firsthand in September 2024, when they were detained by 3 different armies within a single day while attempting to reach the mountain's base. Pakistani border guards arrested the team at dawn for entering restricted territory without proper military clearance. After 6 hours of detention and interrogation, Pakistani authorities released the team with escorts to the border, where Indian forces immediately detained them for possession of climbing equipment in a sensitive military area. Indian military police held the team for another 8 hours while conducting background checks and equipment searches. Upon release, Chinese border patrol units arrested the same team members for unauthorized border crossing, leading to a third detention that lasted overnight. Each army accused the climbers of espionage activities and threatened prosecution under military law. Drone warfare operations have made air support completely impossible for any rescue operations. Military drones patrol the airspace around Muchu Chhish continuously, equipped with air-to-air missiles designed to destroy unauthorized aircraft. The no-fly zone extends 50 miles in all directions from the mountain, encompassing the entire approach region traditionally used by climbing expeditions. Helicopter rescue services have been explicitly warned that any aircraft entering the restricted airspace will be shot down immediately without warning. Electronic warfare systems jam GPS signals and radio communications throughout the region, making navigation impossible for rescue aircraft. Surface-to-air missile batteries provide overlapping coverage of all possible flight paths to the mountain. Climate change has compounded the military barriers with environmental hazards that make climbing impossible even without armed conflict. The glacier system surrounding Muchu Chhish has retreated 400 feet over the past 3 years, exposing unstable rock faces that experience regular collapses throughout the climbing season. The retreating ice removed natural anchors and support structures that climbers had relied on for route security. Geological surveys conducted before the military occupation identified over 200 unstable rock formations that pose immediate collapse risks. Meltwater from the retreating glacier has undermined the stability of approach routes, creating washouts and rockfall zones that change daily. Melting permafrost throughout the region has destabilized the entire north face of Muchu Chhish, creating conditions that make climbing impossible even without military restrictions. The permafrost melt has undermined rock stability in ways that create unpredictable collapse zones across the entire face. Traditional climbing routes, established over decades of exploration, have become death traps as underlying ice melts and removes structural support from rock formations. The North Face experiences daily rockfall events that make approach routes impassable during daylight hours. The magnitude 6.3 earthquake that struck the region in November 2024 fundamentally altered Muchu Chhish's structure by creating new crevasses and unstable sections throughout the mountain. Seismic monitoring equipment detected over 400 aftershocks that continued destabilizing rock formations for weeks after the main event. The earthquake opened new crevasse systems that extend across previously safe climbing routes. Rock faces shifted during the seismic activity, creating overhangs and unstable sections where none existed before. Traditional anchor points and belay stations were destroyed or rendered unusable by the geological changes. Intelligence complications have reached extreme levels as satellite. Imagery of the Muchu Chhish region has been classified by multiple governments, making route planning impossible for potential expeditions. Commercial satellite providers have been ordered to blur or restrict access to high-resolution images of the area. Military intelligence agencies from all three countries monitor satellite imaging requests for the region and investigate anyone seeking detailed topographic information. Climbing route databases have been forced to remove all information about Muchu Chhish to avoid violating national security restrictions. Pakistan, India, China, and Afghanistan now officially consider Muchu Chhish a national security threat, with each government implementing policies that classify any climbing attempt as a military provocation. Attempting to climb Muchu Chhish has become legally equivalent to an act of war, with regional military authorities authorized to use lethal force against anyone found in the area, regardless of their stated intentions or nationality. Yet while military conflicts create absolute barriers above ground, there are places beneath the Earth's surface where the very structure of the landscape continues to change in ways that challenge our understanding of what exploration means. Varovkina cave demonstrates how underground exploration faces challenges that surface expeditions never encounter. The Russian Geographical Society stunned the international caving community in March 2024 when their latest depth measurements revealed that Varovkina cave extends at least 500 feet deeper than any previous exploration had documented. The discovery came during a routine mapping expedition using newly developed laser measurement technology that can penetrate water-filled passages previously thought to be impenetrable barriers. Dr. Alexei Volkov, lead researcher on the depth analysis project, announced that sonar readings indicated the cave system continues far beyond the previously recorded depth of 7,257 feet. Ground-penetrating radar surveys suggest the cave may extend another 1,200 feet beyond current measurements, making it potentially twice as deep as previously calculated. Political instability in the disputed Republic of Abkhazia has made international access to Varovkina cave nearly impossible since the region declared independence from Georgia. Foreign expedition teams now require diplomatic clearance from both Georgian and Abkhazian authorities, creating bureaucratic complications that can take years to resolve. The European Union has imposed travel restrictions on the region that prohibit most scientific expeditions, while Georgia considers any unauthorized entry into Abkhazia to be illegal border crossing punishable by imprisonment. Russian military installations throughout the region have created security zones that restrict movement and require special permits for any research activities. The newly discovered deeper sections of Varovkina cave require specialized exploration equipment that current technology cannot provide adequately. Standard cave diving equipment fails at depths where water pressure exceeds normal operational limits for recreational or professional diving gear. The narrow passages in the deeper sections demand custom-built breathing apparatus that can function in spaces too small for conventional scuba equipment. Waterproof communication systems capable of transmitting signals through thousands of feet of rock and water do not exist in portable formats suitable for cave exploration. Emergency ascent equipment designed for the extreme depths and complex passage systems has not been developed by any manufacturer worldwide. The Warsaw Cave Exploration Society experienced the dangers of Varovkina's changing environment firsthand in August 2024, when their 6-member team became trapped for 19 days in previously unknown chambers discovered during their descent. The team entered what they believed was a mapped section of the cave system, only to discover that recent geological activity had opened new passages while blocking their planned return route. Their emergency communication equipment failed to transmit signals through the altered rock formations, leaving them completely isolated from surface support teams. Rescue operations required international coordination between Georgian, Russian, and Abkhazian authorities despite ongoing political tensions. Climate change has fundamentally altered water flow patterns throughout Varovkina cave, creating flooding risks that make traditional exploration routes extremely dangerous. Increased precipitation in the Caucasus Mountains has raised groundwater levels that feed into the cave system, causing water levels to fluctuate unpredictably throughout the year. Underground streams that were previously seasonal now flow year-round, creating permanent flooding in passages that were accessible during dry periods. Temperature changes have accelerated snowmelt in the mountains above the cave, leading to flash flooding events that can trap explorers in lower sections with no warning. Modern safety protocols now require expedition teams to carry 4 weeks of supplies for explorations that previously required only 1 week of provisions. The extended supply requirements reflect the unpredictable nature of cave conditions and the increased likelihood of becoming trapped due to changing passage configurations. Each team member must carry specialized emergency food, water purification equipment, and medical supplies sufficient for extended underground survival. Communication equipment includes multiple backup systems capable of functioning in the cave's challenging electromagnetic environment. Scientific analysis has identified toxic gas concentrations in Varovkina's deeper sections that render standard breathing equipment completely inadequate for safe exploration. Hydrogen sulfide levels in some areas exceed concentrations that can cause immediate unconsciousness and death within minutes of exposure. Carbon dioxide accumulations in certain chambers reach levels that can cause carbon dioxide poisoning even with standard cave breathing apparatus. Methane gas pockets create explosion risks when combined with lighting equipment or electrical devices used for navigation and communication. No commercially available breathing equipment provides adequate protection against the combination of toxic gases found in the cave's deeper sections. Varovkina cave structure changes continuously as new passages open, while established routes collapse due to ongoing geological processes. Seismic monitoring equipment has detected over 200 minor earthquakes in the region during the past year, each potentially altering the cave's internal configuration. Water erosion creates new chambers and passages, while simultaneously weakening support structures in existing areas. The cave system shows evidence of connecting to undiscovered underground networks that could extend the total depth by thousands of additional feet. The true bottom of Varovkina cave may never be reached due to its constantly evolving nature and the extreme technical challenges that exceed current human capabilities and available technology. While underground exploration faces these dynamic challenges where the very structure of destinations changes unpredictably, surface exploration confronts an entirely different category of transformation where entire landscapes are disappearing at unprecedented rates. The continent that's disappearing. Antarctica faces a transformation unlike any other continent on Earth. The Thwaites Glacier collapse in March 2024 fundamentally changed Antarctica from a challenging destination into a partially forbidden continent. Sections of West Antarctica covering 47,000 square miles became completely inaccessible when the glacier's collapse triggered cascading ice sheet failures throughout the region. The collapse created unstable ice conditions across an area larger than Pennsylvania, with crevasse fields and unstable ice bridges making ground travel impossible. Aerial surveys conducted immediately after the collapse revealed that the ice sheet had dropped by an average of 180 feet across the affected region, creating massive depressions filled with meltwater that freeze and thaw unpredictably. The no-go zones created by the Thwaites collapse extend far beyond the immediate collapse area due to the interconnected nature of Antarctic ice systems. The collapse destabilized ice formations across 120,000 square miles, creating a domino effect that continues spreading months after the initial event. Ice shelves that appeared stable in satellite imagery from January 2024 had completely disappeared by September, taking with them landing strips and supply routes that had served Antarctic operations for decades. The British Antarctic Survey documented over 400 new crevasse formations in areas that were previously considered safe for vehicle travel. Research station evacuations have reduced Antarctica's year-round human population to just 400 people, down from over 1,200 residents who staffed bases during previous winter seasons. The McMurdo station reduced its winter crew from 150 to 45 personnel after evacuation routes became unreliable due to changing ice conditions. Rothera Research Station evacuated its entire winter staff for the first time in 40 years when ice runway conditions became too dangerous for emergency medical evacuations. The reduced human presence has created gaps in critical climate monitoring data collection, just when such information has become most important for understanding accelerating climate change. The Australian Antarctic research team experienced the terrifying reality of Antarctica's changing landscape when they became stranded for 6 months after their planned evacuation route disappeared overnight. The team of 12 researchers had been conducting ice core analysis at a remote site 400 miles from McMurdo Station when a sudden ice shelf collapse eliminated the ice runway used for their scheduled departure. Their Twin Otter aircraft evacuation was cancelled when pilots discovered that the landing strip had broken away from the main ice sheet and was floating freely in the Ross Sea. The researchers survived by rationing food supplies and melting ice for water, while constructing emergency shelters from scientific equipment containers. Antarctic operations now cost 3 times more than previous years due to enhanced safety requirements and compressed operational windows. Insurance premiums for Antarctic expeditions have increased by 400% as underwriters respond to the elevated risks of ice collapse and extreme weather events. The operational season for most Antarctic activities has shortened from 6 months to just 3 months due to unpredictable ice conditions and extreme weather patterns. Research vessels must carry additional fuel and supplies for extended missions since emergency resupply has become unreliable. Ice bridges that previously provided reliable transportation routes now collapse without warning, creating immediate life-threatening situations for research teams. The Princess Elizabeth Ice Bridge, which had supported vehicle traffic for over 30 years, collapsed in July 2024 while a supply convoy was crossing, requiring emergency helicopter evacuation of 6 team members. Crevasses now open and close based on temperature fluctuations that occur daily rather than seasonally, making route planning extremely difficult. Traditional markers and route signs have become meaningless as the landscape shifts continuously due to ongoing ice movement and melting. Satellite communication systems have become unreliable throughout Antarctica due to increased solar activity that interferes with polar region transmissions. Solar storms now occur with such frequency that communication blackouts lasting several days have become routine rather than exceptional events. The increased electromagnetic interference affects GPS navigation systems, making precision location tracking difficult during critical operations. Emergency communication protocols have failed repeatedly when solar activity peaks coincide with emergency situations requiring immediate coordination. Geological surveys have revealed new instability in bedrock formations beneath Antarctic ice sheets, making areas that were previously considered geologically stable extremely dangerous. Seismic monitoring equipment has detected increased earthquake activity in regions where tectonic movement was historically minimal. The removal of ice weight due to melting has caused bedrock rebound that creates surface instability and new crevasse formation. Underground thermal activity has increased in several areas, creating unstable conditions that affect surface ice integrity. Halley 6 Research Station announced plans for permanent abandonment after engineers determined that changing ice conditions make the facility too dangerous for year-round occupation. The Noumea Station 3 has been evacuated temporarily, with no timeline for resuming operations due to unstable ice shelf conditions. 5 smaller research outposts have been officially closed after access routes became permanently impassable. The fundamental irony of modern Antarctic research has reached a critical point where climate change makes studying Antarctica more crucial than ever while simultaneously making the continent less accessible to the scientists who need to study it. Yet while Antarctica's barriers stem from environmental change and logistical challenges, geological forces beneath the Earth's surface are creating entirely new categories of impossible destinations where the very laws of physics prevent human approach. The place that defies physics. Kilwaya volcano on Hawaii's Big Island has created zones where the fundamental laws of physics make human approach impossible regardless of technology or protective equipment. These locations represent the ultimate barrier to exploration, where temperatures, toxic gases, and electromagnetic fields combine to create conditions that exceed the limits of material science and human biology. Unlike remote destinations that challenge endurance or require expensive equipment, these volcanic zones have become fundamentally incompatible with human survival. The Hawaii Institute of Geophysics discovered underwater volcanic vents in June 2024, producing water temperatures exceeding 400 degrees Fahrenheit in localized areas around Kilwaya's underwater extensions. These superheated zones extend far beyond the immediate volcanic source, creating thermal barriers that span several miles in diameter. The heated water creates convection currents that carry extreme temperatures throughout the surrounding area, making approach impossible from any direction. Traditional diving equipment melts within minutes of exposure to these temperatures, while specialized heat-resistant materials prove inadequate for protecting human occupants. Thermal imaging from research vessels shows heat plumes extending over 15 miles from active vents, creating massive exclusion zones where water temperatures remain above 200 degrees Fahrenheit. These heated areas create steam clouds at the surface that reduce visibility to near zero and pose serious respiratory hazards to anyone attempting surface operations. Ocean currents carry the superheated water in unpredictable directions, making the thermal zones mobile hazards that can appear in areas that were previously safe for marine operations. The University of California's Materials Engineering Department attempted to develop heat-resistant exploration technology specifically designed to withstand extreme volcanic conditions. Their prototype incorporated tungsten alloy construction and advanced ceramic heat shielding designed to protect electronic systems and human occupants from temperatures exceeding 500 degrees Fahrenheit. The testing program appeared successful in controlled laboratory conditions until the prototype encountered actual volcanic conditions during deployment near Kilwaya. The vessel's hull integrity failed within 18 minutes of exposure to volcanic gases and extreme heat, with internal temperatures reaching levels that would have killed any human occupants within minutes. The physics of extreme heat create fundamental problems that no current technology can solve because the conditions exceed the basic physical properties of available construction materials. Temperatures approaching 2000 degrees Fahrenheit, which occur regularly in active volcanic areas, surpass the melting points of most metals and ceramic materials used in protective equipment. Heat transfer through any protective barrier occurs at rates that make it impossible to maintain safe internal temperatures for human survival. The extreme temperatures create thermal expansion and contraction cycles that destroy the structural integrity of protective equipment within hours of exposure. Volcanic areas now produce toxic gas combinations that defeat all known filtration and breathing apparatus systems. Hydrogen sulfide concentrations in some volcanic zones exceed 1,000 parts per million, levels that cause immediate unconsciousness and death within minutes of exposure. Carbon monoxide levels reach concentrations that overwhelm standard gas masks and breathing equipment designed for industrial safety applications. Sulfur dioxide emissions create acid conditions that corrode breathing equipment and cause severe chemical burns to respiratory systems even with protective gear. The gas combinations change constantly as volcanic activity fluctuates, making it impossible to design filtration systems that can handle all possible chemical combinations. Electromagnetic fields generated by volcanic areas disable all electronic equipment within several miles of active volcanic sources. The electromagnetic interference affects GPS navigation systems, radio communication equipment, and emergency beacon devices that rescue teams depend on for safety operations. Satellite phones and emergency communication devices experience complete signal failure when exposed to electromagnetic fields generated by active volcanic systems. Electronic ignition systems in vehicles and aircraft malfunction when operating near intense volcanic electromagnetic fields, making mechanical transportation unreliable or completely inoperable. Scientific research has revealed that some locations on Earth have become fundamentally incompatible with human biology due to combinations of extreme heat, toxic gases, and electromagnetic interference that attack human physiology simultaneously. Human body temperature regulation fails when exposed to ambient temperatures exceeding 120 degrees Fahrenheit for extended periods, while volcanic areas routinely exceed 200 degrees. Respiratory systems cannot process air containing the gas concentrations found in active volcanic zones, leading to immediate chemical burns and organ failure. The electromagnetic fields affect human nervous system function and can cause disorientation, seizures, and cardiac irregularities. Geological monitoring stations have documented that volcanic activity areas are expanding due to increased tectonic activity and climate change effects that intensify volcanic processes. Seismic activity has increased by 40% in volcanic regions over the past 5 years, creating new volcanic vents and expanding existing thermal zones. The expansion creates moving boundaries of inaccessible areas that change location unpredictably as geological activity shifts. These volcanic barriers represent just one category of impossible destinations that continue multiplying across our planet. As we have seen from the Arctic to Antarctica, from the deepest caves to the highest peaks, the places we cannot reach are not diminishing despite our advancing technology. Instead, they are becoming more numerous and more dangerous, creating a paradox that challenges our fundamental assumptions about exploration and accessibility in the modern world. The fundamental shift in what defines remoteness has reshaped exploration itself. The most difficult place to reach in 2025 is not a single location, but the concept of true isolation itself. In our hyper-connected world, genuine remoteness has become nearly extinct. Climate change eliminates safe travel windows to previously accessible destinations. Political conflicts close borders that were open for decades. Rising sea levels swallow landing strips and supply routes. As our technology advances, the remaining inaccessible places become exponentially more dangerous and expensive to reach. The irony is clear. We can video chat with someone on the opposite side of the planet, but we cannot safely